Here we have a SAT math problem. Okay, let's go to the question. In the figure above, O is the center of the circle. Measure of arc ADC is 300 degrees. BA is tangent to the circle and length of OB is 8. What is the area of the shaded region? Okay, using the given information, we have to find the area of this shaded region. Okay, my idea to find the area of the shaded region is first we have to get the area of this triangle OAB. Once I get the area of this triangle OAB, I can subtract the area of the sector OAC over here. When I subtract the area of this sector from the area of the triangle OAB, I'll be getting the area of the shaded region. Okay, so if I want to get the area of this triangle, I have to use a formula that is 1 over 2 times base times height. Okay, how do you have to get the base of the triangle and height of the triangle? For that, we have to consider the given information. Okay, the question says BA is tangent to the circle. That is, this line segment BA is tangent to the circle. Since the BA is tangent to the circle, at the point of contact, the angle between the radius of the circle and tangent of the circle is always a right angle. That is 90 degrees. So OAB is a right triangle and OB is the hypotenuse because it is opposite to the right angle. Okay, apart from the hypotenuse OB, let's consider the remaining two legs of this right triangle, that is OA and AB. Okay, so in a right triangle, apart from the hypotenuse, so in the remaining two legs, one of the leg can be considered as a base of the triangle and the other leg can be considered as height of the triangle. Okay, here we can consider this OA as the base of the triangle and this AB as the height of the triangle. Okay, once I get the length of OA and AB, I can use the formula that is 1/2 times base times height to get the area of this right triangle OAB. Okay, now let's try to get the area of the right triangle OAB. For that, let me consider this piece of information. That is a measure of arc ADC is 300 degrees. So the measure of arc ADC over here. So its angle measure is 300 degrees. That is, the angle subtended at the center by this arc ADC is 300 degrees. We know that the angle of full rotation is 360 degrees. That is the angle in a full circle. Okay, we know that here we have a full circle. In this full circle, so the measure of this particular part is 300 degrees. Then what is the measure of this particular part? It has to be 60 degrees. So that when we add this one and this one, we get 360 degrees. Okay, now let's consider the three interior angles of this right triangle OAB. Here we have a right angle and the measure of this interior angle is 60 degrees. Then what is the measure of this interior angle? It has to be 30 degrees. So because in any triangle, the three interior angles will add up to 180 degrees. So here we have 90, here we have 60. When we add them, it's 150 degrees. So the remaining 30 degrees should be over here. So now when we add these three angles, they add up to 180 degrees. And also this OAB is a special right triangle, that is 30, 60, 90 special right triangle, and the side which is opposite to the smallest angle 30 degrees is the shortest leg of the triangle. Usually we assume the shortest leg as, the length of the shortest leg as x. Okay, OA is the side which is opposite to the smallest angle measured 30 degree. So this is the shortest leg. We can assume x as the length of the shortest leg. Okay, the next longer leg is AB, which is opposite to 60-degree angle measure. What is the length of this longer leg? To get the length of this longer leg, which is opposite to 60 degrees, we have to multiply the length of the shortest leg, that is x by square root of 3. So x times square root of 3 is the length of this longer leg. And the length of the hypotenuse is 2x, that is 2 times the length of the shortest leg. But already we know the length of the hypotenuse OB that is given in the question itself, that is 8. 8 is the length of OB, but here we got the 2x as the length of the OB. So both 2x and 8 represent the same stuff, that is the length of OB. We can equate them. Now let's solve for x in this equation. For that we have to divide both sides of the equation by 2. Then this 2 will cancel. Then I'm getting x equals to 4. That is 8 divided by 2 is 4. Okay, now let's replace the x over here by 4. Then I'm getting 4 as the length of OA. And 4 times square root of 3 as the length of AB. Okay, I already have assumed this OA as the base of the triangle and this AB as the height of the triangle. Okay, now we can get the area of triangle OAB. Let me write the stuff over here. Area of triangle OAB equals to 1/2 times base times height. 1/2 times the base is 4 and the height is 4 times square root of 3. 2 goes into 2 one times and 2 goes into 4 2 times. Okay, 1 times 2 is 2, 2 times 4 square root of 3 is 8 times square root of 3. Okay, now I got the area of the triangle OAB. Okay, now mine is to get the area of this sector OAC. Once I get the area of this sector OAC, it can be subtracted from the area of the triangle to get the area of the shaded region. Okay, how do I have to get the area of the sector? There is a formula. Let me write it. Area of sector OAC equals to theta divided by 360 degrees times the area of the circle, which is pi r square. Okay, here theta is the central angle of the sector. Okay, in this case, the central angle of the sector is 60 degrees. We can plug in 60 degrees for theta divided by 360 degrees times pi times. Here this R represents the radius of the circle. Actually, this OA represents the radius of the circle. We got the length of OA, that is 4. So 4 is the radius of the circle. We can plug in 4 for R square. Okay, 60 goes into 60 1 times and 60 goes into 360 6 times. Then we get 1 over 6 times pi times. The value of 4 square is 60, that is 4 times 4. And here both 6 and 16 have the greatest common divisor 2. So that is 2 goes into 6 3 times and 2 goes into 16 8 times. Okay, now let's multiply these three values. 1 times pi is pi, pi times 8 is 8 pi, and in denominator we have 3. Okay, now I got the area of the sector. Okay, now our aim is to get the area of the shaded region. Let me write the stuff over here. Area of the shaded region. Let me write it. Area of the shaded region equals to, so to get the area of the shaded region, we have to subtract the area of this sector from the area of the complete triangle OAB. So the area of the triangle OAB is 8 times square root of 3 negative. The area of the sector is 8 pi over 3. Let me write it. So this is the area of the shaded region. We find this stuff exactly in answer choice C. The correct answer choice for this question is C.